Okay, here we go. Last section, last bit of trigonometry. I think this will be fairly easy for you. They're giving me a little triangle. So this is just putting trig information in little right triangles. That's all this is. So they're putting that little angle theta in a right triangle there. They're saying A is 13 and B is 8. And they want me to find the sine of theta. They're going to want me to find all 6 trig functions. Let's start with sine. How do you find the sine of angle theta up there? Well, do you remember, I bet you do, the SOHCAHTOA stuff? SOHCAHTOA for doing sine, cosine, and tangent. So that's about opposite, adjacent, hypotenuse, all that kind of stuff. Now, from theta's perspective, it's always from the angle's perspective. From theta's perspective, this is the hypotenuse, right? The hypotenuse is always the side across from the right angle. The side right here, A, this side is what? Is that adjacent or opposite?
Adjacent.
That's the adjacent side because it's right next to it, huh? Adjacent, that's what it means. It means next to it, like your neighbors live adjacent to you, next to you. And this side is the opposite. B is the opposite side from theta's perspective. Now, if theta was down here, if theta was down there, then this would be the adjacent, wouldn't it? Because that would be the side next to theta at that time. So there we go. Okay, so with that in mind then, now we can answer the question. Sine is opposite over hypotenuse. So sine, bring it down here. So sine is opposite over a hypotenuse. So that would be 8, the opposite, over the hypotenuse. Oh, we don't have the hypotenuse. I got to get the hypotenuse. So how do I find the hypotenuse? Pythagorean, a squared plus b squared is c squared, right? So we'll do that. A squared plus b squared is c squared. So 8 squared plus 13 squared is the hypotenuse squared. So it's at 64, 169. What's that? 222. Is it 233? Is that right? Okay. And then root it. So that's it. So root of 233 is the hypotenuse. Great. And so root of 233. So then sine is 8 over root 233, opposite over hypotenuse. Good to there. But we can't leave roots in the bottom, as you know, so we have to multiply top and bottom by root 233. So we get 8 root 233 over plane 233. So there's the sine. Now we can find the cosine. What's the cosine? Adjacent over hypotenuse. So just grab the adjacent, 13 over the hypotenuse. Root 233. Let me write it here first. Adjacent over hypotenuse. So 13 over root 233. And then can't have a root in the bottom, so multiply top and bottom by root 233. Get 13 root 233 over plane 233. Good for cosine. And then tangent. So SOHCAHTOA, tangent is opposite over adjacent, so opposite 8 over adjacent 13. Boom, that one's done. Don't need to get rid of any roots on the bottom. Doesn't have a root on the bottom. So there's sine, cosine, and tangent from SOHCAHTOA. They want all 6 trig functions, so they want the other 3 as well. So the other 3, how do you get the other 3? There it is, flip it, huh? Upside down, upside down, upside down. So upside down of sine is cosecant. Upside down. Now the easiest way to flip it and not have to mess with the root thing is flip it right here while the root was on the bottom. And that'll put the root on the top. Excuse me, on the top. Be a little quicker. And then opposite of upside down of cosine is secant. Same thing, flip this one right here. Root 233 over 13. And then upside down of tangent, cotan. Flip the 8/13s, 13 over 8. There we go. We got all 6 trig functions, and you probably could have done that without me helping. I bet you already knew how to do all that from your trig days. SOHCAHTOA, right? On the right triangle. Questions on that one? Is that good? Everybody okay with that one? Any other questions on that one? All right. So I saved an easy section for last. I thought you'd enjoy that. You've done all the hard stuff. So there's not much to this section. Try that one. So they're giving me B is 6. I think you've done all these before. Know just how to do them. B is 6. Beta is 50 degrees. Notice how they said they're going to do these solve the triangle things. They always put the same letters across from each other. So notice, let me make it a little bigger and just talk about that for a minute. Probably be helpful to you. They put B across from beta. That's a Greek B, right? They put those guys across. Do you realize, do you remember from trig that angles affect the sides across from them, don't they? Right? Because as I open my hands like an angle, as you open an angle, what gets bigger is the side across from it, huh? Angled openings affect the side opposite them, don't they? As they get bigger and smaller. So, do you realize that in any triangle, which side here is the smallest? It looks like this is the smallest side, huh? Across from him will be the smallest angle. And this is the largest because this is the hypotenuse. So across from him is the largest angle. And this is the medium side, so across from him will be the medium angle. Do you realize they're all connected like that? Small angle, across from it, smallest side. Medium angle, across from him, medium side. Large angle, across from him, largest side. Because an angle opening affects the side opposite, right? So they go together. They're paired up. Angles and the sides across from them. So if you keep that in mind, and then that's what they do with the naming scheme. See how they call this B and this B, basically. It's a Greek B and an English B. They call these guys both A, a Greek A and an English A, because they're across from each other. So they'll always set up the naming schemes thusly, that way. Okay, so let's go through it. What do they give me? Beta, B, and that's it? Okay. So, what should we do first? What can we find easily in this triangle? What do you know right away? Do you know angle alpha? What's it got to be? What's angle alpha got to be? 40. Got to be 40. Good. How'd you know? Samuel, how'd you know? Just came to you. Just a flash.
No, because if you assume all the angles, you got to be 180.
Exactly. Yeah, remember that all the angles in a triangle always make 180, right? Angles in any, not just a right triangle, but any triangle, total 180. So therefore, if you have 90 already used up, right, if you have a 90-degree angle, that only leaves 90 left for the other two. So the other two have to make 90. Yes, oops. So I can just take 50, or 90, I should say, 90 minus 50, the other one's got to be 40. So this one here has got to be 40 degrees, doesn't it? See, those two have to make 90, and then the right angle's 90, 180. Good, so we got that one. We got alpha, so we have all three angles, so that part's nice. Now we can start finding the sides. Have to find all, or two sides. We've already got B. Okay, so how do we start finding the sides now? You need some kind of trig relationship, sine, cosine, or tangent, that involves one of the angles and one of the sides. You want to use this side and A together. Why? Why can't I use C and A? Because I don't know C and I don't know A. You don't want two unknowns. You with me? So when you set up some trig relationship to find a missing part, make sure you've only got one unknown thing. So I'm going to use A, which is what I'm trying to find here, and B, which I know, and then whatever angle you want, doesn't matter. Like how about 50? You can do the 40, doesn't matter at all. I'll just say, all right, I'm going to use the 50-degree angle, the 6, the B, which is 6, and the A. What trig relationship involves those three? Sine, cosine, or tangent. Remember SOHCAHTOA? SOHCAHTOA. So from the 50's perspective, the angle, remember, it's always from the angle's perspective. If you're going to use it, you could use the 40. That'd be fine. But I just chose to use the 50. Okay. So from the 50's perspective, this is the hypotenuse, this is the adjacent, and this side is the opposite, isn't it? So when I say I'm going to use the 6 and the A, that's opposite and adjacent, isn't it? So what trig relationship uses opposite and adjacent. Tangent. Tangent. So tangent of 50 degrees is opposite over adjacent is 6 over the little a. Y'all tracking with me? So hit the buttons on your wall. I'm just going to leave it like this for a minute. Tangent 50 is 6 over little a. I need to solve for little a. Put this over 1, diagonal, diagonal. So a tan 50 is 1 times 6. Right? The last step to get a alone. Divide by tan 50. Divide by tan 50. There it is. A is whatever 6 divided by tan 50 is. Make sure you're in degree mode. And I'm getting 5.03. Rounded to 2, they said hundredth. So I got it. 5.03. Questions on that? That makes sense for how to find little a? One more step and we're done. The last thing, we found all 3 angles. We found 2 sides. We only got 1 side left to go. And we got everything. That is side C. They want me to find side C. So how do I find side C? Could I use a squared plus b squared is c squared? Yes, but I wouldn't suggest it. Why? Because you'd be using a, which is a rounded number, and it might throw your final answer off. It's always best, if you can, to use non-rounded numbers. Numbers that they gave you. I mean, it'd work. If you used a couple more places of accuracy, you could make it work, and that'd be okay, and it'd be good. But I'm going to just, oops, I'm getting confused here. I'm going to instead I'm just going to say, look, I'm just going to do the 50, the C, and the 6. Because that way it's all stuff I know for sure, nothing's rounded. So what relationship involves the 50, the 6, and the C? That's opposite and hypotenuse. Opposite, from the 50, opposite hypotenuse, that's sine, huh? Sine of 50 is opposite over hypotenuse is 6 over C. So put this over 1, diagonal, diagonal. C sine 50 is 1 times 6. Divide by the sine of 50. Divide by sine of 50. C equals whatever that is. 6 divided by sine of 50. I'm getting 7.83. And we're done. So that's easy. You've all done that before, haven't you? Y'all know about that already, right? Good. Questions on that? Solve the triangle. Good? All right. Okay, so this was a little different. This time they're giving me A is 6, C is 7. And notice they're not giving me any of the angles. So first off, you can find the little b with the Pythagorean, right? So go ahead and do that. That's a good way to start. Find the little b with the Pythagorean. A squared plus b squared is c squared. So what's that? 6 squared plus b squared is 7 squared. 36 plus b squared is 49. Subtract 36, b squared is 13. Rooted. B is the root of 13, which is whatever it is. I don't know. It's 3.61. There we go. Got B. That wasn't too bad. Now, though, how do we get angles? We don't have alpha or beta. See this? How this one's different? We don't know alpha or beta. We know the right angle, the 90, but we don't know alpha. We don't know beta. How are we gonna get those? What do we do? Anybody know? Yeah, we end up doing the inverse. Yeah, I would first off say, look, I'm going to set something up involving the 6, the 7, and like the beta, for example. You could have started with the alpha, doesn't matter. But notice I'm not choosing the 3.61 because that's a rounded number. So what trig relationships involves the beta, the 6, and the 7? Let's do the thing. This is hypotenuse. This is adjacent to the beta. From the beta's perspective, that's adjacent, and this is opposite. So we're looking for a trig relationship. Remember SOHCAHTOA. a trig relationship that involves this side adjacent and this side hypotenuse. Adjacent and hypotenuse. Which trig relationship is that? Cosine, huh? So the cosine of beta is adjacent over hypotenuse is 6 over the hypotenuse 7. Is 6 over 7. So cosine beta is 6/7. Good so far. How do I find beta now? What am I going to do to get rid of that cosine and get beta alone? You know, right? Inverse cosine. Both sides cancels. So beta is inverse cosine of 6/7, whatever that happens to be. Calculator told me 31.00 degrees. Rounded to two places, it came out 0027, so 00. 31 degrees, right on the money, 3100. So got beta, 3100 degrees. How do we get alpha now? Subtract from 90, huh? Right, because alpha and beta got to make 90 because the other right angle 90 is 180. So alpha will be 90 minus 31, which is 59.00 degrees. So we got beta, we got alpha, we got everything, we're done. Oh, this is alpha actually here, huh? Got alpha, got beta, weird, and bless you. And we're done with that one. Is that good on that? Remember all that? You've done all that, huh? Questions? Easy. Be one of these on the final. You'll be able to nail it out. All right, I'll move on. All right, so I'd encourage you to draw it. And the hypotenuse is 9. Let's put that there. One angle is 38. Find the length of each leg. So think for a second. Remember the small, medium, large thing we talked about? Smallest angles, across from it is the smallest side. Medium angle, across from the medium angle is the medium side. Largest angle, across from the largest angle. Well, that's the 90, huh? The 90 is the largest. Across from him is the largest side, the hypotenuse. So, which side is the smallest? It's this. At least the way I drew it, this one's the smallest. And this one is going to be actually the medium. It's the longer of the two legs. Right? So that means this has got to be the small angle. Boom. And this has got to be the medium angle. Boom. Right? You're with me? And if one angle is 38, one of them, it's a right triangle. So you got 90. One angle is 38. What's the other angle? Whatever 90 minus 38 is, huh? Which is what, 52? The other angle's 52, isn't it? So the other angle, so which one's the medium angle? That's a 52. And the smallest angle is the 38. So you got to be a little careful on the small, medium, large because they're specifically asking you the shorter and the longer on this one. So you see how I set that up? Now, can you find the shorter side and the medium side? Try that out. Let me give you a second. Try some SOHCAHTOA trig relationship. See if you can get the smallest side and the medium side, which they're calling the longer leg. It's the longer of the two legs. So I'll take the 52, for example, and I'll say, okay, this is adjacent opposite, hypotenuse. So I want to use the 52, the medium, and the hypotenuse, because you only want one unknown, right? So that would be opposite hypotenuse, so SOHCAHTOA, opposite hypotenuse, that's sine. So sine of 52 is opposite over hypotenuse, is the medium side over the hypotenuse of 9. So put this over 1, diagonal, diagonal. So 9 sine 50 degrees is 1 times the medium. So the medium equals whatever 9 times sine of 52 is. So that's 7.09. Or they want the nearest tenth, don't they? So they just want me to say 7.1, I guess. So the medium side, 7.1. That's the longer of the two legs, 7.1. Is that good? And then I'll do the smaller. So for the smaller, with the 52, that would be adjacent over hypotenuse. So adjacent, that's cosine. So cosine of 52 is adjacent over hypotenuse, is the small side over the hypotenuse of 9. Put this over 1, diagonal, diagonal. So 9 cosine 52 is 1 times the small side. The small side is 9 cosine 52. 5.5 is the small side. Now you could have used the 38-degree angle and done different trig functions, and that would have been fine as well. Those are the answers you should get however you do it. 5.5 for the small one, 7.1 for the bigger one. Is that good? Questions on doing that? All right. There we go. All right, can you find that distance A to C? So they want to know. They want to know that distance. What is that distance? Give that a try. Some trig relationship involving that. Okay, so from the 40's perspective, this is opposite, and this is adjacent, and this is hypotenuse. So we're looking for opposite over adjacent. SOHCAHTOA, opposite adjacent, that's tangent. So the tangent of 40 degrees is opposite over adjacent is the opposite, the side we're looking for, the A, I'll call it AC, the AC distance right here, over the adjacent, which is 150. So put this over 1, diagonal, diagonal. So 150, tangent 40 is 1 times AC. So the AC distance is whatever 150 times tangent of 40 is. And it came out 125. I don't know how far they want it rounded. 0.86 or whatever. Did y'all get that? That good? Questions on that? I'll move on. No questions? Is that too quick? So you're headed towards a plateau. 70 meters high. So it's like you're walking along a path, and then there's this plateau 70 meters high. The angle of elevation to the top of the plateau is 25 degrees. What is the angle of elevation? It means take the flat horizontal and elevate up until you see the top of the whatever you're looking at. So that means right here, this angle of elevation is 25 degrees. It's the angle elevated up from flat, from horizontal. Is that making sense? Angle of elevation. It's elevated from flat and up to where you see the top of the thing. So they're saying, you know, if you raise up 25 degrees, that's when you sight the top of the thing. They have instruments that'll do that, right? They have lasers now that you raise up until you see the top of whatever shape, and you know the angle from the horizontal, angle of elevation. So they're asking, how far are you from the base of the plateau? What's this X? How far? Here's the base of the plateau. Here's where you are. This is you here. How far are you? What's X? What's your distance from the base of the plateau? So do you realize how you could use it? If you're far away from some mountain or you're out in the ocean and you see some lighthouse, right? If you have the instrument that measures, if you go up till you sight the top of the lighthouse or whatever, and you just happen to know, you can go type into Google how tall lighthouses are. Lighthouses are, I don't know what they are, 100 feet tall or 200 feet tall or whatever. So if you know, okay, that's 200 feet tall lighthouse, from where I'm at in the ocean, my angle of elevation to spot the top of that lighthouse is 25 degrees. How far am I from the beach? You can actually calculate using trigonometry how far you are from the beach. This is how they program various equipment that calculates exactly this. So see if you can find X there. How far away are you? What trig relationship is it? It's tangent again, right? Because this is opposite, adjacent, hypotenuse, SOHCAHTOA. I want opposite and adjacent. That's tangent. Tangent, 25 degrees. Kind of getting scribbly there. Tangent, 25 degrees, is opposite over adjacent, is 70 over x. Put this over 1, diagonal. X tan 25 is 1 times 70. Divide by the tan of 25. Boom. X equals 70 divided by tan 25. And I'm getting 150. How far do they want me to round? Round 2 decimal places. 150.115. So the second decimal place rounds to be 12. 150.12 is how far away. So you calculate how far away you are from something based on the angle and knowing how tall the thing is. Good there? Questions? State troopers hitting 30 feet from a highway. So this is 30 feet from the highway. 1 second after a truck passes, the angle theta between the highway and the line of observation from the patrol car or truck is measured. See illustration. If the angle is 14, so they're saying if this is 14 degrees, how fast is the truck traveling? Answer in feet per second. Oh, so no, that's just a fancy way to say, what is this distance x? Because he covered that distance x in 1 second, it says, right? So how many feet that is, that'll be his feet per second, because he did that in 1 second. So, give that a try. Can you find x there? So from the 14's perspective, so from the 14, from this angle theta's perspective, This is the opposite. This side is the adjacent. And this is the hypotenuse, because here's the right angle, huh? We good? So this is opposite and adjacent. So SOHCAHTOA, opposite adjacent, tangent again. Somebody's always tangent, huh? So the tangent of 14 degrees is opposite over adjacent is 30 over the adjacent, the x. Call it x, call it a, whatever you want to call it. Okay, so then put this over 1, diagonal, diagonal. So x tan 14 degrees is 1 times 30, divide by tan 14 degrees. Boom, 30 over tan 14. I'm getting 120. 2 decimal places of 120.32. That's how many feet, and he did that in a second. So that's feet per second.
You know how many feet in a mile?
Do you know how many feet in a mile?
I have it right here on my phone.
So we're good to there so far, because I think we are going to need to change it over in a second. So everybody good to there? 120.32 feet per second. That's how many feet that truck traveled in that 1 second. Right? 120.32. Okay, now, if you got that, I'll move. So now we want to convert that answer, 120.32, to miles per hour. So let me write right here, 120.32 feet per second. Now, do you guys know how to convert units?
Just multiply that by.
It's a little tricky. I really learned it in chemistry class. I don't know if you're taking chemistry, but they really instruct how to convert units. There's a lot of it in chemistry. So basically, when you're wanting to convert units, you cancel them out. Units cancel just like anything cross cancels. So in other words, you always take your next step by what you want to get rid of. In the end, I want miles per hour. That's a fraction, isn't it? Miles over hours. Miles per hour. I want miles per hour in the end. Okay, so what does that mean? That means I got to get rid of feet. I don't want feet. I want miles. So if I want to get rid of feet, where am I? And feet are up top right now. Where am I going to put feet to get rid of them? On the bottom, right? Gonna put feet on the bottom. Okay, so that'll get rid of feet, won't it? Units cross cancel like anything else does. Now, what do you want to go to? What do you want on the top? Well, miles. They want miles per hour. So put miles up here. Okay. Do you know a relationship between miles and feet? Yeah, if you look it up on Google, you don't have to memorize this. 1 mile is 5,280 feet. So 1 mile is 5,280 feet. I knew which way to put this because I wanted feet to cross cancel. If I was to, right? You guys good so far? Have you seen this in chemistry, how to convert units? If I was to stop the problem right now, I'm not going to, I'm not done. But if I was to stop the problem right now, what units are left standing? Miles on the top, seconds on the bottom. Whatever that comes out to be, it's miles per second. What do they want? Miles per hour. So I got to keep going. Okay. Next. What am I going to do for my next fraction? Well, what are you trying to get rid of? What do you have that you want to get rid of? Seconds are on the bottom, and I don't want seconds on the bottom. I want hours eventually. So seconds on the bottom. Where are you going to put seconds if you want to get rid of seconds? Got to put it on the top, and that'll get rid of seconds. See how you know where to put stuff? You cross cancel. Now, you could go straight to hours. That's a little hard, though. Why work hard? I can go easily to minutes. I know that off the top of my head. 1 minute, 60 seconds. If I was to stop the problem right now, what units are left standing? Miles on the top, minutes on the bottom. Do I want miles per minute? No, I want miles per hour. So one more step. What am I motivated to get rid of? Minutes. Where am I going to put them? On the top, so they'll go away. And you can easily go to hours. 1 hour is 60 minutes. See how that was? And if I stop now, it's miles per hour, isn't it? See how easy that is if you follow the yellow brick road of just canceling units? That'll convert you from feet per second to miles per hour.
Of course, it's faster if you
Any numbers on the top, you multiply. Any numbers on the bottom, you divide. So just take 120.32 divided by 5280 times 60 times 60. Numbers on the top multiply. Numbers on the bottom divide, times 60, divided by 5280. Any order. You can just go 60, 60, then do 5280. Doesn't matter what order.
You make it slightly faster if you know how many seconds are in an hour.
3600, yeah, you could do that. How many places I want? Oh, one decimal place. So I'm getting 82.0 miles per hour, 82 miles an hour. That truck's going to get a ticket. 82 miles an hour. Everybody good with that? Conversion process?
Now get ready to do it a second time.
We'll go into that, but that's the same thing on that. Is that making sense? Is that good on that? Let me say a word about the